All right. Well, thank you all for joining us for this online FP Talks. I, as the organizer of this workshop, want to begin by saying welcome. Thank you all for coming. It's really exciting to be holding a workshop on the state of the art in numerical representations and floating point error. We've got some very exciting speakers coming up. We've got 16 talks throughout the day today. And as organizer, I'm not only excited about the speakers, I'm also excited about the fact that we have over 70 participants from over 35 affiliations scattered all across the world. And really looking forward to what happens when we put this all together. The FP Talks formula at a high level is something like this. So if we take cutting edge research in numerical representations and floating point error, and then we combine that with some short workshop style talks, I think that what we ought to get is an open academic dialogue that makes our research and our field more accessible to practitioners, to implementers, to amateurs, to those outside the formal academic space. And because this is the first time that we're holding FP Talks, my hope is that not only is this formula hold, but it also holds regardless of small rounding errors. So FP Talks is organized under the FPBench umbrella, and I'll be telling you a little bit more about the FPBench project in just a little bit. But it is also being sponsored by the Applications Driving Architectures Center, that's JUMP Center, organized by DARPA and the Silicon Research Corporation. And thanks to their sponsorship, all of the speakers will be getting a snazzy FPBench t-shirt in the mail. So look out for that, and thank you to the ADA. But let me first tell you a little bit more about FPBench. FPBench is a project that we started organizing, I think somewhere around 2016. And the idea of FPBench was to strengthen our community by building community resources and doing some community building for this academic research into numerical representations and floating point error. So I'd like to tell you just a little bit about the projects that we've been doing under this goal. And I'll start with some community resources that we've been working on. Maybe the most obvious community resource that's in the name are the benchmarks. So we've collected something like 130 benchmarks from different published research papers and also unpublished work by researchers in this area. We've collected them and added metadata describing example inputs, error tolerances on those benchmarks, what sorts of, where those benchmarks might be used, and citations where those benchmarks have been benchmarked against. Now, those benchmarks on their own, you know, a benchmark is a benchmark, but to make them more usable, we've also built a set of compilers. And those compilers can transform this benchmark code into languages from Mathematica all the way to JavaScript so that you can use them as input to any research tools you're building. And not only do those compilers do a direct translation, there's also a set of transformations that we've implemented for this benchmark language that we've developed. So we can automatically do things like loop unrolling, common sub-expression elimination, or function inlining with the pre-built tool. So this is something that basically you can use to modify the benchmarks to suit your use case. Maybe your tool doesn't support loops, or maybe it needs preconditions in a certain format, and automatically transform them into that to make it that much easier to get started using these benchmarks. And finally, these benchmarks, they're in a standardized format that we've developed. We call it FP Core. And not only is this an easy to parse and unambiguous syntax, we've also built some careful semantics around tricky things like library function calls, mixed precision code. And as you'll hear from Bill after lunch, our most recent release of the standards, FPBench 2.0, also includes support for tensor computations. So these are resources that you can go ahead in your research, in your work, and use them right now. You can contribute benchmarks or download the benchmarks that we have already. You can use the compilers to transform them, modify them for your tool, and you can support this FP Core format as a standard input format for any tools that you develop. So let me actually take a quick break from this presentation and just show you directly what those tools and resources are like. This is the event webpage, and at the top you can directly see links to the benchmarks, compilers, and standards. So let's start with the benchmarks. And here on this benchmarks page, you'll see a list of all of the benchmarks that we have. You can click on any one of them and see additional information they may have. So you'll see here that these benchmarks not only come with pretty extensive preconditions, as well as the program itself, which in this case is pretty simple because the precondition that makes the benchmark complex. You see that they're also annotated with precisions, and in some cases also citations for further examples. Like, for example, here you can see citations to papers and books that these benchmarks are sourced from. You'll also see that at the bottom we've linked to a few external tools. If you're developing a floating point or numeric representation tool that can take FP core inputs and is accessible over the web, please let me know, because we'd love to make this, we'd love to add a link to your tool right here, make it even easier for people to discover your work. So we've got this whole list of benchmarks here, but not only that, this list is also searchable. So I can search for a specific benchmark by name, like this. I can search it also by which operators it is using. Like, for example, if my tool has just implemented support for the exponential operator, I can search specifically for the 16 benchmarks that have it and download all of them. And you can even search directly for tools, for benchmarks cited in or used in a particular paper. And you can just download basically a little kit to reproduce the results of that paper. And you know, I'm sure this benchmark suite could grow and become even better. So we're open for contributions, and please, if you have benchmarks you use to evaluate your tools, whether they're in this FP core format or any other format, please click this link, contribute to our benchmarks over GitHub. I also mentioned that there are compilers and standards. The compilers, you can find instructions for installing them on the website, and you can see that it basically provides a way to export our benchmark format to any other language, and there's quite a long list, as well as transformations that you can do, like common sub-expression elimination. Finally, you can browse the standards right here, and this includes the standards that we've just released, handling tensor computations and function calls. So you can browse those right here. You'll see the benchmark format, the syntax, detailed description of the constants and functions supported, as well as a description of the semantics. So you can browse that at your own leisure, but please do and use these in your own work. I think you'll find it can be quite helpful. But besides the resources that we've developed, the benchmarks, the compilers, and the standards, we've also recently been pushing to do some more community building as well. The first place we started is gathering a list of papers using the FPBench benchmarks, making it easy to compare your work to other work that's using the same benchmark and find papers that might be good baselines to compare your work against. But we've also expanded that into a list more or less comprehensive of all of the floating point research tools and numerical representation tools out there. These are loosely organized. They're maintained by Mike Lamb, and you can find those on our website as well. And then finally, maybe the most recent example of community building we're doing is this very workshop, which we're hosting for the first time. As I've said in the emails that you've received, all of these talks will be recorded. They'll end up on YouTube, and hopefully they'll make our field more accessible to others. So these are also places where you can contribute. You can add yourself as a user of the FPBench benchmarks, explore the list of floating point and numerical representation tools we've collected. And of course, all of you are already attending this workshop, so you've already gotten started. So that's FPBench, which is the sort of community resources and community building project we've been doing. And if you'd like to find out more about that, go to fpbench.org. And now I want to tell you, just to wrap up, a little bit about the logistics of how FPTalks 2020 will work. You're already all on Zoom, so you know that that's how we're doing it. The schedule is going to have 4 sessions, each an hour long, covering really exciting talks from sort of all over the spectrum of floating point and numerical representations. You'll note that the talks are spread pretty widely through the day with generous breaks. Partly that's to make it possible to attend FP Talks and to give talks despite the global pandemic from across the world. But that doesn't mean that FP Talk stops happening during these breaks. I'd like to invite you to continue discussions and any sort of further questions you have for the speakers on two tools that we've set up, Slack and Gather. If you're not familiar with them, Slack is this group chat application, and we've set up not just a general channel for FP Talks, but also some specific channels if you'd like to learn more about the benchmarks, the compilers, or the standards. So that's a great place to discuss anything that you want to know about FPBench. But of course, you can also use it to discuss any talks that you see, ask further questions of the speakers, and so on. The other tool that we've set up is something called Gather. Gather is this kind of like informal social chat application using video chat. You sort of have an avatar where you can walk around the world, and when you're close to people, you can see their video feeds and talk to them. I used it for the first time about a week ago for the PLDI conference, and I think it's pretty exciting, so hopefully you'll check it out and see if it works for you. And you can find links to both Slack and Gather on the main event website. You've also received them in your email. So just a bit about the logistics. This is a Zoom meeting, so please keep your microphones muted. However, we will be taking questions live. If you open the participants panel, there should be a button at the bottom of your screen labeled participants. You should see a button that says raise hand toward the bottom of it. And you can click that, and that will tell me as the moderator of the session that you'd like to ask a question, and I'll call on you and the speakers will answer questions. So that's how we'll do live questions for the speakers. Finally, I should note that all of the talks are being recorded and also live streamed to YouTube. What that means is all of these talks will be accessible afterward, and hopefully we'll make high quality recordings of them available on the website shortly after FP Talks is over. If you've got any questions that you want to ask about FP Talks, if you have technical difficulties, you can contact me. Probably best is contacting me on Slack. I've got a second screen on my right here, and I'll be on Slack the whole time. So if you have any questions or technical difficulties, you can ping me directly with a direct message on Slack, or you can join the support channel if you think your questions are sort of more generalizable that someone might be able to help you out. So with that, I think those are the basic logistics out of the way. I don't want to take up too much time. I want to jump right into some of the really exciting talks that we've got going. So in summary, welcome again, everyone, to FP Talks 2020. I hope you are as excited as I am for the next day of talks. And with that, I'll open the floor up to questions.